Here's a warm-up for you to do. I'd like you to convert to radians or degrees. Press pause, and then when you're ready for the answers, press play again. Here are the solutions. If you got one wrong, take a minute and double check your work or ask a friend. We are going to look at the different trig functions today as they relate to a circle. So we have sine, cosine, tangent, cosecant, secant, and cotangent. Now, if you recall from geometry, the phrase SOHCAHTOA referred to sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So, also yesterday we learned about reference angles. And the reference angle is the angle formed with the terminal side of my angle and the x-axis. So in this second quadrant, my reference angle is right there. So as we're talking about the trig functions, we're talking about them in relation to the reference angle. So if I think about a right triangle, sine again is opposite over hypotenuse. And in a circle, the opposite side is y, and the hypotenuse side is the radius of my circle. So this would be y over r. Cosine is adjacent over hypotenuse, and that then would be x over r. Adjacent, x over hypotenuse, r. Tangent is opposite over adjacent, or y over x. Opposite y, adjacent x. Now, cosecant is the reciprocal of sine. So, cosecant is hypotenuse over opposite, or r over y. Secant is hypotenuse over adjacent. It is the reciprocal of cosine. In terms of our circle, that is r over x. And finally, cotangent is the reciprocal of tangent. So that is adjacent over hypotenuse, or x over y. This is all really important, and you need to have this memorized. So if you need a minute more to write it all down, press pause. When you're ready again, press play. So let's look at another example. It says that I have a coordinate 4, -3. It's a point on the terminal side of my angle theta in standard position. So the very first thing I'm going to do is I'm going to draw it. So 4, 3. 4, -3 would be in the fourth quadrant, and there is the point on the terminal side of my angle in standard position. So, I don't like where that went. Let's try it again. So I have my angle here. It's in the fourth quadrant. So I want to find sine, cosine, and tangent of that angle theta. Now, recall that I am dealing with this right triangle. I always drop an altitude to the x-axis because all my trig functions are determined based upon that reference angle. So in order to find sine, cosine, and tangent of my angle theta, I need to know what x, y, and r are. I can see that x is 4 and y is -3. Now, X and Y can be negative, but R is always positive because it's the radius of my circle. And you can picture that there is a circle here that just is not drawn. So in order to find R, I'm going to use Pythagorean theorem. And you'll recognize this as a 3, 4, 5 triangle. In this case, R is 5. If you don't recognize that, you need to use the Pythagorean theorem. Legs squared plus legs squared is equal to hypotenuse squared. 4 squared plus, I'm going to put in the negative 3 squared, which is always positive, has to be equal to R squared. That's 16 plus 9 is R squared, or 25 is R squared, which would give me a radius of 5. Now that I know all of these pieces, X, Y, and R, I can find any trig function that I want, because I know that sine of theta is Y over R. Well, Y in this case is negative 3. R is 5, so sine of theta is negative 3/5. Cosine of theta is X over R, and X in this case is 4. R is 5, 4/5. And tangent of theta is Y over X. Y is negative 3, and X is 4. So, in summary, we draw our point. We then draw in the triangle so that it forms, we can see that the angle, the reference angle is part of the acute triangle, part of one of the acute angles in my triangle. We solve for the missing pieces, X, Y, or R, and then we substitute into our trig function formulas. Try this one, press pause, and when you're ready for the answer, press play again. So here's the answer. You can see that I have plotted my point, negative 512, in the second quadrant. I drew my angle in standard position. I then knew that X was negative 5, Y is 12. I used Pythagorean theorem to find R. In this case, it was a nice Pythagorean triple. 5, 12, 13, and then I substituted into my formulas for my trig functions. So sine again was Y over R, cosine was X over R, and tangent is Y over X. Now the next thing I want to be able to do is determine the quadrant of an angle. The way you do this, you'll notice this is negative 645. So clearly I've had this angle spinning around in a negative fashion, which would mean it is going in a clockwise direction. So I would like to find an angle that is coterminal with negative 645, meaning it lands in the exact same position. So in order to do that, I am going to repeatedly add 360 to this until I end up with an angle that is somewhere between 0 and 360. So if I take negative 645 and I add 360 to it, I will find that first I get negative, here, let's draw that in. I'm going to add 360. I get negative 285, which is still not in between 0 and 360. So I'm going to add 360 again. And I find that 75. Now I've got to picture my quadrants. My first quadrant is at 90 degrees. Second ends at 180. Then my third ends at 270. 360. So the 75-degree angle, which is coterminal with negative 645, meaning the terminal side lands in exactly the same position, because I'm unwinding my angle, 75 degrees is in quadrant 1. Now, the second angle is in radians. I'd like to know where that angle ends up. Now, in order to know that, I have to picture my quadrants. This angle is at pi over 2, pi, 3 pi over 2, and 2 pi. I typically will see this as 0.5 pi, this as 1 pi, this is 1.5 pi, and that again is 2 pi. Now, if I look at 21 pi over 4, I can take the 21 over 4 and see that is 5.25 pi. Now, that is clearly past the 2 pi. So what I'd like to do is I'd like to unwind it and see where it lands between 0 and 2 pi. To do that, I'm going to keep subtracting 2 pi. So in my calculator, I take 5.25, I subtract 2, I find that is 3.25 pi. I still am not between 0 and 2 pi, so I'm going to subtract 2 again, and that is 1.25 pi. When I look at my quadrants here, it's easy to see 1.25 is between 0 and 2. From here to here is 0.5. Then I have 0.5 to 1, 1 to 1.5, and that tells me that this angle is in quadrant 3. So that angle's in quadrant 3, this angle's in quadrant 1. I want you to try these. Press pause on your video. When you're ready for the answer, press play again. And again, we find angles that are coterminal. In number 1, I would add 360 to this repeatedly until I found a number between 0 and 360. So, actually I said add 360. I would subtract 360 repeatedly until I find that that is coterminal with the angle 315 degrees, which is in quadrant 4. This is negative 9/4, which is negative 2.25 pi. So to this one, I'm going to add 2 repeatedly until I get something between 0 and 2 pi. This actually is coterminal with 1.75 pi, which is also then in quadrant 4. Trig functions signs by quadrants. It's important to know the sign of a trig function in each quadrant. Now, if you think about what each trig function represents, you can easily tell whether it would be positive or negative. Remember, R is always positive. So every single trig function that we know is positive in the first quadrant because x and y are positive and r is always positive. In the second quadrant, sine is positive because it's y over r, y is positive there. Cosine is negative because x is negative there. Tangent is negative because tangent is y over x and y is positive and x is negative. And then cosecant is the reciprocal of sine, so that's also positive. Secant is the reciprocal of cosine, so that's negative. Cotangent is the reciprocal of tangent, so that's also negative. Now in the third quadrant, x is negative and so is y. So sine and cosine are both negative. But tangent, that's the ratio of y over x, is positive since they're both negative. And then again, I can think about the reciprocals, and they are going to have the same signs as well. If I look at the fourth quadrant, I would recognize that x is positive and y is negative. So cosine is going to be positive and sine is going to be negative. And tangent will also be negative because x is positive, y is negative. So sine is negative, cosine's positive, tangent's negative. The reciprocals work as the same way as well. Cosecant's negative, secant is positive, cotangent is negative. Now, I think about what each function is in terms of x and y on my coordinate plane. Some people, there is another way to remember it. All students take calculus. All are positive here. Sine is positive here. Everything else is negative except the reciprocal of sine. Tangent is positive here. Everything else is negative except the reciprocal function, cotangent. In the fourth quadrant, cosine is positive. Everything else is negative except the reciprocal of cosine, which is secant. I personally think it's easier just to remember it in terms of x, y, and knowing r is always positive. So I'd like to take a look at these trig functions and determine whether they should be positive or negative based upon the angle. The first step is to find the quadrant of each of the angles. So again, we have 1,395. We are going to say that that's going to be equal to sine of 1,395 minus 360. And I'm going to keep subtracting 360 till I get an angle that is coterminal with that, somewhere between 0 and 360. So I subtract it once, I get 1,035. I'm going to subtract it again. That gives me 675. Subtract again. That's 315. So sine of 1,395 is the same as sine of 315, which is in quadrant 4. In quadrant 4, sine is negative. So I know that I will get a negative value for sine of that angle. For the second problem, same kind of idea. I have to know the quadrant. So I know that negative 9 divided by 4 is negative 2.25. I'm going to add 2 to this. This is negative 2.5 pi. I'm going to add 2 pi. That's negative 0.25 pi. Add 2 again. That gives me 1.7 pi. And I believe these are angles that we had just done, but oh well. So I know now that this is the same as tangent of 1.75 pi. That is in quadrant 4. And in quadrant 4, tangent is negative. That concludes the lesson for today. Check out your homework assignment, which is online. Have a nice day.